אני הולך להעביר את מה שחיים דיבר עליו, שאנחנו רוצים בעצם שהם תבואו עם נושאים אלינו ואנחנו נציג אותם. אז חלק מהמטרות שאנחנו רוצים להגיע מעבר, כאילו, מטרה ראשונה זה לעודד ושיהיו הרבה תוכן מכם מהקהילה. המטרה השנייה, שיהיו כמה שיותר חברי קהילה שירצו לא רק פה, אלא ירצו בכנסים בחו"ל, שאין לנו הרבה יותר נוכחות, שידעו מי זאת קהילת Java.IL. בעולם, כמו שיודעים שיש הרבה קהילות חזקות, כמו הקהילה של לונדון, הלונדון ג'אג, קהילה מאוד חזקה. אז לכן, ההרצאה הזאת, אני עבדתי לה מאוד קשה, כנראה חעביר אותה בעוד שבועיים בדנמרק, בכנס של ה-Java User Group של דנמרק, שנקראת, אז הכנס נקרא J.D.K.I.O. אז ברשותכם, הייתי שמח להיעזר בכם, הקהילה, להעביר אותה באנגלית, אם לאף אחד לא אכפת. אז אחרי זה גם נשמח גם לפידבקים. אז זהו, אז אני עובר לאנגלית. השאלות כמובן בעברית, אין בעיה, כאילו אני אענה בעברית. כי בקיצור, תרגישו חופשי לשאול שאלות באמצע, זה לא כמו בכנס. אז אוקיי. 2 years ago, I started my new adventure in software, which actually means I started looking for a job. So I did, sorry, זה לא יהיה בכנס. So I did, I went to many interviews, I think 50, but this one company got my attention. And during the interview, I usually ask, because I'm a clean code guy, I really like testing, and I ask, do you guys have testing? And the reason I even asked it in this startup was they were only 8 months old. And in 4 months, they're going to be in GA. And usually in this stage, you're very pressured, you don't have a lot of time, you want to get the product done. And he said, yeah, sure we do. And it was very surprising. We have a full end-to-end test suite, and it's running here on my laptop. I'm running a mini logs.io, this is the name of the company. And he showed me, I was like, I want to work there. And where do I sign up? So this was my moment when I entered into testing in the Docker era. And Docker actually fundamentally changed the way I write tests and I look at tests. And I want to share that with you today. So as I said before, my name is Asaf Mesika, and the company that I interviewed was logs.io. It was 2 years ago. I started as the second backend engineer, as a senior core developer there. And I think to understand the use case that I will present today, it's a good thing to understand what logs.io does. So logs.io is in the log analytics domain, same as Logly, Sematext, Splunk Cloud, and Sumo Logic. Essentially, there are 2 main things that we do. The first is ELK as a service. So everybody needs, it's a tool that you all need, logging and an ability to index all the logs and search in one place. So the open source that everybody uses is ELK, and it's usually very hard to set up in very large deployments. So what we did, we took the open source, this is the differentiator for other vendors, we took the open source and enabled it as a software as a service, which means it's very easy for you to use. The second thing, most of the problems that we see for customers are the volume. So there's a large amount of logs, I mean millions, if not billions of logs a day, and it's very hard to really focus on the really important ones. So we created an AI engine for us to locate and focus on those logs, to find those important logs. But the main difference for these algorithms that are based on crowdsourced data. And crowdsourced data is actually you, the developers. The places that you go to ask questions, so any Q&A sites, the forums or the mailing list that you go to when you post questions and stack traces. And we use that for the input for the AI engine. It's quite cool. And now, to really understand how Docker changed the way tests are written, it's first we need to understand, to go back to the basics and understand why are we writing tests. I mean, what do we do in everyday job? So we write new features, write new behaviors, or we modify an existing code, not changing behavior, like bug fixes and etc. And when we do that, we want to deploy the system, right? We just modify the code and want to deploy it to production, but we're scared because we change the system. It's usually not a small system; it's a large system, and we are afraid just to put it in production, just like that. So the reason that we write a test is to gain confidence. So essentially, tests are for us to gain confidence. And it's also for us to gain the ability to trust and get the confidence to make the jump and deploy to production. And most importantly, deploy it in a stress-free manner. This is the reason we actually write tests. Now, when you think about it, the developer's holy grail, like the fantasy of every developer, is to have this magic button. The magic button, we can just press play, and suddenly the code that we just changed will be thoroughly tested from every input, every angle, and instantly deployed to production. Everything very fast. That's the developer's dream. But in reality, we don't have that, right? So we need to gain that confidence. But how do we do it? We write tests. But tests usually, they come with a price. And of course, they don't thoroughly test everything. And most importantly, they're not instant. And essentially, if you think about it, the first price we pay is duration, the time it takes to run the tests. And the second one is the overhead, the time it takes for us to set up the environment and to be able to even start running the test. So this is the price that we pay. But we gain, and the gain is confidence. And when you think about it, those three items are actually dimensions. Dimension we can analyze and understand the different types of tests that we write. Now, those dimensions I came across when I saw this amazing 5-part series in Google Hangout. It's recorded between 3 people: Martin Fowler, Kent Beck, and David Heinemeier Hansen, and the guy that invented Ruby on Rails. And they talked about these TDD dead. So I really highly recommend watching this series. It's a bit long, but it's worth it. OK, so let's begin. What is the first type we all write? It's unit test. And usually the unit of work when you write a unit test is the normal is the single class, right? You take a single class, you instantiate it, and you test it. I don't think that's a really good idea. I think it's probably even better to take a couple of classes, but we'll talk about it in the next slides. Now, when you instantiate the class, you usually, when you write your system, you don't write just one class, right? When you write a feature, you don't just write one. You separate it to multiple classes. There are so many design patterns that enables you and encourage you to do so. So when you instantiate your class, usually you inject user constructor the dependencies, the classes that you depend on, right? Because you split it. And there are 2 ways to do it. And Martin Fowler, in a blog post for 2014 called Unit Test, described 2 styles of supplying those dependencies. One is called the mockist, and the second is called the classic. So let's take an example of a mockist. Here's a code example of just plain class. I bet you all have account service, and there's the constructor. You have 2 classes here. You see the account DAO and an event publisher. So you instantiated your mock account DAO and your mock event publisher. It's a one-liner using Mockito or any other framework, and there you go. You start writing the test. Now let's dive into the code, and we have those lines in the class. And it says, OK, the account DAO.get settings on account ID. And again, remember, this is a mock object. So in the mock object, we need to prepare it. If it's called with this account ID or any, we need to return something. What do we return? An account settings, another class, and it's a mock. Now, on that mock, next line is like that get plan on user type row. And we need to know that we're going to call this line, and we're going to return another mock. It's a plan. And on that plan, we're going to, the code says get max allowed users, and we need to mock that as well, and says if this call happens, you need to return 5. So what really happened here? Just a second. We essentially have two problems. One is we have a multi-level mocking, which I think is really hard to reason about when you read the test. And the second thing is, which is the worst, is we made a coupling between the production code, our code, and the test code. Now, what happens when you do that? Let's say that you want to refactor. We are all as a developers encouraged to reduce our technical debt, to always find new way to make the code more readable and concise. So we try to we refactor. We don't change the behavior. We take 2 methods and turn it into 1. We take a bunch of code and separate it to another class. Now, what happens when we did this? The test breaks. Now, how can we trust? Remember, we wanted confidence from the test. This is the goal. How can we trust the test? We just modify the code, want to press play, and say and check if it's okay, not to be scared. But the test breaks. We need to fix the test in order to use it. How can we trust it? So we lost confidence. This is the thing that we wanted from the beginning. And so this is the mocking style. The second style, but you have a question, sorry?
אני חושב שקצת הגזמת פה, כי יכול להיות שכאילו צריך להיות דוגמה בסדר, אבל בדרך כלל בשלב הזה של השורה השנייה זה כבר value ואתה לא באמת צריך.
מה זאת אומרת?
חזר שם איזשהו value בדרך כלל.
כן, חזרנו באיזשהו
value אתה לא צריך לעשות mock, אתה...
חזר account settings object, ואתה בזה שמכין את המוק צריך לדעת מה אתה מחזיר, כי זה מוק. נכון? כל קריאה, עכשיו על account דאו, המוק, הוא לא מחזיר, אתה קובע לו מה הוא יחזיר. נכון? אין לו ברירה.
צריך להחזיר mock שלך.
הוא מחזיר value, נכון, אתה יכול להכין account settings, אבל הרבה פעמים, בהרבה מצבים שאני רואה, מקוד שאני רואה, וגם אנשים עושים, טוב, שאני אעשה mock. אני אעשה mock ל-account settings, ואני אעשה mock לזה. אם אתה יכול לעשות את זה, זה אחלה, וזה באמת מעולה, וזה טוב, אבל בהרבה מקרים אנשים פשוט נשאבים לזה. זאת אומרת, אנשים נשאבים למוקינג. כי זה קל, כי זה זמין, זה שורה אחת, זה קל.
אז הטענה שלך היא נגד extreme mocking ולא נגד mocking.
נכון. נכון, אני לא חושב שמוקינג באופן כללי זה דבר גרוע, יש לזה, אני לא חושב שמוקינג זה דבר זוועה, אני חושב שיש לזה את השימושים שלו, אני פשוט נותן גם את הצדדים שבהם אנשים משתמשים בצורה לא נכונה. כן, אפשר כמובן לעשות ב-account settings, אפשר לעשות new ולשים את האלמנטים, ויכול להיות שהוא יקבל הרבה אלמנטים, יכול להיות שהוא יקבל 7 או 8. אז אנשים אומרים, מה, אני אעביר עכשיו 7 או 8 אובייקטים, כאילו כל הפרמטרים שאתה צריך בשביל לפילד של account settings, לצורך העניין, יכול להיות שיש לך איזה 7. ואז זה נהיה קשה.
אני חושב שזה נפוץ כאשר בעיקר מנסים לעשות יוניט טסט לקלאס אחד. במיוחד שהוא משתמש בקלאסים רבים. זאת אומרת, אם ניקח, כמו שהגדרת, אולי תגיע לזה, לקבוצה, ואותה נעשה לטסט.
כן, זה בדיוק מחבר אותי לדבר הבא. זאת אומרת, וברשותכם אני אעבור לאנגלית. So the other style that we use is we use the classic. So I'm a classic guy. I try not to mock. And Martin Fowler, which wrote the blog post, also said he is the classic style. So what do? You instantiate the account service, and then you instantiate the real account DAO and the event publisher, and that's great. But you essentially in this style, you reach a point where you're stuck. When you get into a corner in the wall, and that wall is an external resource dependency. So you don't create a database, you don't create Consul or Redis, and in a unit test, right? It's hard to do that. This is where this gets awkward, as he said, and you're forced to do something else. And what do you do usually? There is another type of test that helps you to, again, gain the confidence that you need because you're stuck. And that type of test, before we go that, let's just have a quick summary. So in terms of price, we hardly pay any price. I mean, duration, it's almost 0. Most unit tests methods are like 5 milliseconds. The entire test suite can take like a couple of seconds. And about overhead, the time it takes to set up, no setup, just press play and you can run the test. So the price is low, but the gain, like the goal that we wanted, was not achieved. We haven't really used the real dependencies. We haven't really used all the stuff that we gained. So the confidence that we want, or the question is, once the unit tests are green, can we go to production? Most don't. Most write another type of test to address the problem that we didn't use the real dependencies. And those type of tests are end-to-end testing. So how does an end-to-end testing looks like? Usually it's like you provision your entire system. All the blue stuff, you have the microservices, and the real Kafka, and the real Redis, and the real Mongo, and the real MySQL. But there are a lot of problems with this approach, right? You provision the entire system, and you run the test. But if you're lucky, it's a one-click deployment. Not so many companies, it's one click. So it just takes time to do it. A lot of time, it's a shared environment. So what happens if you have a shared environment? You get in line. There is a queue. And it takes time. It's a lot of time you deploy from a release branch. You don't really deploy from your feature branch. And what happens when you want to fix a bug? You somehow managed in this deployment to find the bug, you fix it, you want to deploy it. Oh no, I have to merge it into the release branch or some shared branch. Get in line, it takes time. And what happens? The duration usually is not in the scale of milliseconds, seconds, or minutes. It's usually sometimes in the scale of hours. So the duration is high. The overhead, the setup it takes, it's high. Right? It's not one click and 10 seconds you have the system. So you pay a very high price, but it's worth it. You get the confidence you wanted. What does this mean? If the tests are green, you are stress-free, and you can deploy to production. Really cool. That's great. That's why we actually write them. So what do we really want? So what we really want is a test that can have everything. Low price on duration and overhead, and high gain, confidence. And it exists. It's called integration test. So what if we can combine both the small duration and the low setup of unit test, and use the real dependencies as an end-to-end test, and more. So we want to use the real dependencies. We want to write it using JUnit, which is a tool that we use easily, like in unit testing. We want to be able to run it on our laptop as opposed to an end-to-end test, and of course on the CI, on your Jenkins server. And the most important, we want a fast feedback cycle. We want to run, and after a reasonable time, know if it passes or not, and gain the confidence because we use the real dependencies. Now the question is, of course, how? How do we do it? And as you assume from the title, it's using Docker. So essentially, just before we dive to this slide, how many people here are using Docker in production? Okay, I say about less than a quarter. How many are using Docker in your development environment? Okay, even less. Okay, so probably need to explain what Docker is a bit. So the reason that we don't, what Docker, the reason that the problem that it's solving, that when you try to run, to download using the real dependencies, it's very hard. Try to download and run a software like Graphite, which is written in Python on Mac, and then the same will work also on the CI server. Same goes for Postgre, MySQL, Redis, everything that is not specifically Java. And try to do it, and it work on Mac, on Linux. It's very hard. So Docker solves that. Docker essentially enables you to, it's a software first that you install on your laptop, of course on your CI. It's very, very simple. It's very, very simple. And so this, once it's installed, it allows you to package essentially any binary. So any open source product you can think about in any language it is written, to package it and then run it on any platform. I mean Mac, Linux, Windows, even Windows. And so this is the great thing about Docker. Now the second thing that the company created something called a Docker Hub, which is a repository for images, for ready-made images, packages, which means that if you're lazy, you have probably any open source product in the world has an image in Docker Hub. And the third thing, if none found and you need something on your own, it's so easy to do it. I mean, you have a Docker file, which is a text file, with commands that you specify what you want to install. I mean, it's very easy to read, to create, so you can create your own image. So this is Docker. Let's see how easy it is. I can install it on my Mac, on Linux, and run this command. So Docker run, I give it a name, I choose which ports I want to expose outside, and then I give the URL from Docker Hub for the image I want to run, and this is an example for running Graphite. And I press enter on this command, and that's it. I have Graphite running. That's it. I mean, 3 years ago, when I worked here, by the way, I tried, I think it took me 2.5 days just to get Graphite installed and running, to get to this point. And this took me like 5 seconds. And of course, you can do Docker stop. Okay. Another example is you can do, you can customize it. You can say, I want to mount a specific file, a configuration file called storage schemas onto inside the Docker. So you can create your own configuration file and mount it. So I specify this command line and I configure it to my needs. Another thing you can do is inject environment variables using this command line -e. So again, another way to customize a ready-made image. And the third is you can mount out directories or files. So you can mount outside to your laptop or the log directory, so you can easily see what happens if something goes wrong, and of course it does. Okay, so this is great. I just showed you a command line. Now we're talking Java. We're in a Java conference, and so we can try to do it using run shell commands from Java to run those commands, but it's not it's cumbersome. It's not really convenient. You need to parse the output. It's not very good. So lucky for us, Docker daemon has an HTTP API. It's over TCP socket, but it's essentially HTTP. So you can easily use HTTP to do the same commands I just showed you. Run, stop, which is great. But lucky for us, someone created a library in Java, a Docker Java client, which uses the same HTTP. The problem with that, it's quite verbose. Everyone who tried to use that, so how many lines you need to do the commands. Lucky for us, this guy wrote a library called Testcontainers, which makes it extremely easy to do the start and stop and everything you need to do in the context of a test. So just everything you can think about that you only need for testing, it has it. And by the way, one small thing I will say only here, that Moshe Eshel is here. Hi. So maybe get up. So this is the guy that was the inspiration for this library. אז כל הכבוד, באמת. So he wrote it in the About Me, and I didn't know, but he approached me, and then I discovered. So I think the best way to really learn about this library and everything that I talked about is watch a real quick demo. Okay, so for this demo, what I did, there's an open source library. I think many of you know. It's called Drop Wizard Metrics. It's really a great library for exposing metrics in Java and to JMix. It also has a feature it's an open source. It also has a feature that enables you to report those metrics like every 10 seconds or a configurable time, report them to Graphite. So I cloned the repo, and there is a class there that says it named Graphite, which Graphite has many protocols for sending data to it. That's why they have the interface. So there is a connect, and you see אתם רואים טוב? There is a connect, and there is a send, and the class that I showed you before, Graphite, is the TCP protocol. Now, let's try to test this class. Only two really important methods, send and connect. So I wrote a class for it. So let's see. First, I do a new generic container, and I give the image that I saw before in the command line. I also specify the specific version. And you can see below, I can do this and start, and that's it. I have Graphite running from the unit test. Amazing. Now, other options are really useful. First, you choose the ports that you want to expose to the outside, that you can use from outside. Second, again, you want to mount the log outside, so when things fail, you can see the logs of Graphite and understand what happened. And of course, it happened to me while I wrote this.
For which library do you get these classes, the generic one?
The Testcontainers library.
Ah,
So I do with file system bind. I give it a temporary directory that I created, and I said mount the varlog carbon out. Next, another really useful method. It's called with class path resource mapping. So I prepare the carbon conf and other configuration, and I place them in the Java in the source test resources directory here, and then I simply says with class path resource mapping, specify the class path, specify where I want it to be mounted, and that's it. And it's mounted, and then it's customized to my test. Same goes for the other three that I needed to customize. Now, when I do start, what I really want is it's very useful that it only I get to the second line to finish the start once a Graphite is actually up. So you use what's called a host port wait strategy. That's one of many. That you can say that when the port is ready, this first port, you can continue, and it's considered up. And of course, with a timeout of 10 seconds. And another one, which is extremely useful, that you can direct all the std out and std error to your logger. So you can see it when you run in Jenkins and stuff doesn't work. You can see the log of the container together with the log of the test. It's extremely useful. And that's it. I have start. Now let's look at at an example for testing connect. I instantiate new Graphite, right? Unit test, right? I give a local host, and this is the local host for the Docker daemon, and a Graphite container get map port, because Docker creates random ports for me on the machine to prevent collision. So I take it, I just instantiated it, right? So the host and the port, and I have a Graphite, and I do that connect, and I know it works, because if nothing fails. Let's see another example for testing the write. Same as before, instantiated it, and then do a .connect. I prepare a metric to be sent, and the Graphite.send, the metric name, the value, and the system type. I call a flash and close, and then I use an HTTP API, HTTP library to actually assert. So get the value, and then assert that the value actually is the same metric and the same value that I expected. So when I actually run it, at least for me, I know that I can trust this code, because it really works with the real Graphite. Now let's run it, of course, just to see an example. That's it. Now, I put a small timer for the before class. I measured only the before class. So it took me 5 seconds. Of course, the test itself was 1 second, but the setup took, so it took me 5 seconds, and the entire test, like, I guess, 7 seconds. So this is the time it takes to run. This is the price you pay when you used it. Now, again, I said it's an open source library, right? So they must have a test. Then they need the confidence, right? So let's take a look at the test. I wrote an iTest, and they called it Graphite test. So let's just minimize this one. OK, so let's see how the test looks like. OK, so a mock socket factory. And then I have a mock of a socket, and I have a spy on a byte array output stream. OK, and then let's see how the setup looks like. Atomic Boolean, connected closed, and then when socket dot is connected, then answer invocation on mock, connected dot get. OK, when socket dot is closed, then answer invocation mock, closed dot get. And then do answer invocation mock, connected dot set close, when socket dot close, when socket dot get output stream, then output. OK, I don't know what about you, but I'm completely confused. I think I will take a notebook just to read the setup method. Now, let's assume that everything goes OK. This is the way. Let's see how that actually tests, right? So they do a new Graphite, and they give it an address, quite good, and then a socket factory. Wait a minute. I didn't use a socket factory when I instantiated it. I just gave it localhost and a port, right? A host and a port. So they needed a way to do it in mock, right? It's writing to a socket. And they needed a way to assert on something that goes on. So they needed to change the actual code, make it much more complicated, to introduce a socket factory, only to be able to introduce a mock. So this is what David Anson Hennemeyer called in 2014 test-induced damage. So actually damage your code for the mocking to be enabled, to test in mock. So, and then they do, let's forgive them, and they do Graphite Connect. And how do they know it actually works? They verify if the socket factory was called, a method called create socket was called on the socket factory with the address and the port. OK. And then they test, let's see how they test write. They do a new, they instantiate, connect, they send the name value in 100, they close, and then how do they know it works? They assert that the output, like the mock of the mock of the mock of the buffer output stream inside the socket, it looks like this. Now, this is the finished version. Of course, it works because you see the finished version, but I bet you that the developer who wrote it really started a real Graphite to actually debug and test his code to know it actually works. There's no way that it would deploy his code to production, this library, deploy his code and release it without knowing it really works. So, just a second, I saw it, just a second. And so, in summary, I think it's to the time so the time it takes. Of course, this runs in milliseconds, and so I would happy pay the price of running this test, and it would take me a few seconds every time to get what I wanted for the first place. So it's a confidence to deploy my code.
Your example is biased because what you're testing here is integration. So obviously an integration test will test integration. That's why it's called that.
Do you think they have integration tests?
You're not testing business logic.
You think they have integration test? They don't. I checked. That's it.
Fine.
No, that's the
against,
no, but that's the point.
Against testing integration test, where what you need to do is test integration test. Of course, it's the best thing to do.
Okay.
But this is not business logic. What I'm saying is that the example that you give is okay for integration test, definitely. But testing with real objects or Docker containers makes very little sense when what you test is a business logic.
I want to imply that this is an opinion. And my opinion is, again, this is something that I tried over the last 2 years, is that, and I want to I want to, if it's okay with you, this point that you talked about is like the main point of the lecture, and we get to it just at the end because it develops, okay? But I will give you like a good answer at the end. Okay, so this concludes the demo of test containers. Okay. So what you saw here is really not exactly, I mean, it's not really an integration test. It's more, I would call, a component test. So what do you mean by component test? If you think about it, the unit test is the unit of work is a class. And in integration test, many times the unit of work is a microservice. So in component test, there's a new type of test that you can do. And this type of test enables you to test one or more classes. But as opposed to a unit test, you actually use the real dependency. And I want to present an example from logs.io. So in logs.io, we have one of the microservices we have called a log receiver. So as you remember, logs.io is in the log analytics. So we receive, the servers are sending logs to us. We index them and enables you to search on it, right, using the UI. So obviously we have a microservice that is responsible for listening and receiving the logs that you send. And then we, as the first stage, write it to Kafka. So this microservice has a lot of components inside. One of them is called the Kafka writer. So it's a class that you just write log, and it writes to Kafka. And this, now what happens is sometimes Kafka may be unavailable or fail. And when that happens, we don't want to drop the log on the floor, so we want to persist. So we write it to a file system. And we, of course, don't want to write a mega class. We have another class called log file sync, which writes it to the file system. So we simply use it. So we instantiate the file sync, and we use it in the Kafka writer. Now, what happens is when you can test it in integration test. I mean, you can start the microservice and then start playing with all the non-happy flows that happen. What happens if Kafka is down? What happens if a partition decided to move between one broker to another? And the non-happy flows, I found it very convenient and very easy to reason about when you write it using a unit test, but using the real dependencies. So this is what I called it component test. Another example is for integration testing. So we zoom out. We have the same microservice that we saw before. This is the blue box log receiver. And this is the unit of work in the integration test. The unit of work is the log receiver. And we use the real dependencies. So using test containers or compose, there is another method for doing that. You can start and have the real Kafka, the real MySQL. And in this example, the log receiver is able to receive in many different formats. HTTP, UDP, TCP, and there is a specific protocol Elasticsearch decided to write on their own called Lumberjack. It's essentially a protocol over TCP. And the only software in the world that is able to write using this protocol, version 2, is called Bits. It's written in Go. And so I simply used a ready container for it, again from Docker Hub, for Bits, and it sends only an SSL, so I have an Nginx, again, using a test container. I started up, and then wrote logs to the directory. It's mounted, it reads the log from it, sends it to the log receiver, and the log receiver writes to the Kafka that I just started, and then I read from Kafka and assert that actually the thing worked. This specific code that I wrote, the Lumberjack input in this example of the protocol actually works. So this is an example of an integration test.
In this flow, you described how you load an environment and run the test, right? But what infrastructure do you have in order to test the entire flow, so that when you send the message, it's written right on the logs, and the format of the logs are correct?
And what do you mean infrastructure?
איזה תשתית אתה משתמש בשביל בסופו של דבר לבדוק את כל המערכת שלך שהיא עובדת. בסדר, הרמת דוקר, הרצת טסט, עכשיו אבל צריך מישהו שיבדוק שמה ששלחת זה מה שאתה מצפה שייכתב ומה שנכתב.
כן, אתה מדבר על השקף הבא, שזה ה-Endtoend testing, שזה עושים עוד זום אאוט, ומסתכלים על בעצם, מקודם דיברנו על Endtoend כמשהו ש... אופס, סורי. So before... כן, אתה הורס את ההכנה. זה לא יקרה בדנמרק. כן, ישראלי ישתל שם. So in end testing, that I talked about before, you provision, right, your entire system and you test. But here, you can do something very, very cool, that you can actually take a thread or a flow in the system and compose it, right? So you can, in this example, I chose to test I chose the flow, so I simply chose an input, an HTTP log shipper. We have the microservice called the log receiver, and it writes the log to Kafka. We have another microservice that reads from Kafka and index the documents, the logs to Elasticsearch as documents. And then we have another microservice that enables us to read the logs, to query, and it receives the query by HTTP and goes to Elasticsearch, gets the data, queries the Elasticsearch, and returns the result. And this is a client. So this is an entire flow you can do on your laptop. And this is what they call an end-to-end.
אוקיי, אז יש לך האם אתה צריך לכתוב את כל הקוד בצורה נקייה בג'אווה בשביל לשלוח את ההודעה ולקרוא בסוף מה נכתב ולהשוות שזה מה שאתה מצפה או במה אתה משתמש בשביל
התשתית, תראה...
לנהל את התהליך שמצד אחד שולח, מצד אחד בודק מה...
אוקיי.
ואומר לך פייל או סקסס
אוקיי, תראה, הכלים שאני השתמשתי בהם בשביל הטסט הזה הם obviously דוקר מותקן, Testcontainers זה ספרייה, איזשהו HTTP קליינט בסיסי בשביל לשלוח את הלוגים, קצת עטוף, אתה יודע, שאני אשים את הטוקן שלנו והכל, כאילו authentication, בשביל לדעת אם, שוב זה end-to-end, זאת אומרת, אז הדבר הבא שאתה עושה בשביל האסרט, אתה פונה בעצם למיקרוסרבר של log query, ואתה גם כן בעזרת HTTP קליינט, מגיש query באיזשהו פורמט מסוים, ורואה שהתוצאות שקיבלת מתאימות בדיוק ללוגים, כי עשית query שיתאים בדיוק לתוצאה הזאת, לצורך העניין. אז זה כאילו הכלים שהשתמשתי בהם.
הכל בתוך ה-JUnit?
כן, 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 הכל בתוך ה-JUnit.
יש לי שאלה, אמרת לפני זה, שכמה לוקח לך להריץ טסט אחד שמריץ קונטיינר ויעבוד אותו?
זה תלוי. זה כמובן מתייחס בסוף גם בשקף שם.
שאמרת מיליסקנד ולי לוקח לפחות 5-10 שניות.
אתה מדבר על ה-unit test או על זה?
אני מדבר על להרים קונטיינר.
לא, להרים קונטיינר לא לוקח מיליסקנד, זה unit test. מה שאמרתי שהמחיר פה זה מחיר שכן, זה שניות. זה לא ברמה של מילי שניות.
הרבה כאלה וגם כל אחד הוא לא דטרמיניסטי.
לא הבנתי?
מניח איך אתה עושה את זה, אתה מסתכל על פורטים, פתוח, אתה מניח שהתוכנה שלך מוכנה, נכון? אבל לא תמיד מצב, יכול להיות שאתה יודע, בקלאס עדיין לא תוכל.
לא, ברור שאתה... לא, זה כן דטרמיניסטי, בוא נגיד עד 99% נקרא לזה. זאת אומרת, השיטה הכי פשוטה... לא, השיטה הכי פשוטה שלפחות אני מצאתי, זה שאתה פשוט עושה איזשהו wait until כזה, שאתה משהו בספרייה, אז wait until, אתה מחכה שהכל למעלה. שוב, בעזרת דוקרים, טסט קונטיינר זה ממש קל, כי אתה אומר לו, אני רוצה שהפורט יהיה פתוח, למשל, במקרה הבסיסי הזה, אבל יש דברים שהם אפילו יותר distributed. למשל, אתה, לא יודע, אתה מייצר אקאונט במיקרוסרוויס אחד, והוא, אתה יודע, צריך לחכות שהוא יתעדכן.
זה שאתה כותב לדאטאבייס, והטסט שלך עולה אחרי זה לקרוא מהדאטאבייס, ויצאת בעולם לא דטרמיניסטי.
למה לא דטרמיניסטי? בגלל שאתה, לא, אוקיי. לא, ברור, אני מבין את השאלה. תראה, העניין הוא...
עדיין לא יהיה באמת מוכן.
כן, אני אסביר את השאלה, אני אחזור עליה. יש... מה שהוא מדבר עליו זה שבעצם לגבי, שוב, אני הבנתי את השאלה של ה-MySQL ספציפית, זה שכאילו הטסט הוא לא דטרמיניסטי בזה שאני כאילו מלכלך את הדאטאבייס, ואז עוד טסט גם כן משתמש בדאטאבייס המלוכלך, אז קודם כל יש לזה שתי פתרונות.
לא, אני אומר, תריץ את הטסט הזה.
אז לא הבנתי את השאלה?
10,000 פעם תריץ את הטסט, פעם אחת הוא לא יעבור לך, זה אומר שהוא כבר לא דטרמיניסטי.
למה הוא לא יעבור?
למשל, אם אני כתבתי את הקוד שלי ככה שהוא פותח פורט, כן? ומכין אחר כך איזשהו קלאס, אבל בדיוק בדק שהפורט עובד, והקלאס עדיין לא מוכן, והוא כבר שלח את הבקשה, אז הקלאס יפיל נגיד את הבקשה הזאת, והטסט לא יעבור, סבבה? במקרה אחר, הוא כן הספיק לעשות את זה, והטסט כן יעבור. זה תלוי פה בתקשורת, זה תלוי פה
תראה, אני אגיד לך, אני אשמח לדבר איתך על זה כאילו בצורה ארוכה, כי נראה לי שזו שאלה טיפה יותר ספציפית, אבל אני אגיד לך רק באופן כללי, שלגבי החוסר דטרמיניסט היחיד ששמתי לב אליו, זה, הוא בא לידי ביטוי אני בדרך כלל תופר את זה באיזשהו, כמו שאמרתי, איזשהו wait until, זמן נראה לי שהוא עם time-out סביר כדי שהדבר הזה יהיה למעלה, או שהתנאי שאני מחכה לו יהיה למעלה כדי שאני אוכל להתחיל את הטסט. הדבר השני שאני פותר את הבעיה של חוסר דטרמיניסטיות זה גם עם namespacing, זאת אומרת, אם אתה עושה reuse לאותו דאטאבייס, אבל שוב, הדבר הזה מאפשר לך גם לעשות את ה-isolation, זאת אומרת, זה מאפשר לך להרים דאטאבייס נקי ריק, אם אתה צריך, אוקיי? לא, זה אני רק אומר. אז ברשותכם רגע, הייתה עוד שאלה אחת?
כן, פה בעצם מה שתיארת זה יותר סיסטם טסט. כלומר, מראים מערכת שלמה ולבדוק. אני אומר, יש כלים שלפחות אני משתמש, אנחנו משתמשים, כלים כמו קיוקמבר בשביל לבדוק את זה, ואז בעצם זה ליתרון שגם מי שלא מתכנת יכול להגדיר את הסט של הבדיקות, וגם מתכנת יכול לממש אותה.
זה נכון, אני אדבר על זה בשקף האחרון, אני רואה בזה בתור חיסרון, אבל זה עניין של גישה. נטו.
אבל זה לא, שנייה, לא קשור, זה לא סותר, אתה יכול להרים מאחורי קיוב, קונטיינרים, כאילו...
אתה יכול, נכון. אני אדבר בדיוק על הדברים האלו ממש עוד מעט, ברשותך, אז אני אחכה לזה לשאלה, ותקבל את התשובה לשאלה שלך. אוקיי, אז ראינו שתי סוגים של... sorry. So we saw the type of the test we can write using of course, Docker and Testcontainers in Java. So essentially, this is what we saw. So essentially, what happens today, like in the pre-Docker era, the ratio of tests looks like this. What is called the pyramid approach. So the pyramid approach, you as a developer, you see you have a lot of unit tests because it's really easy to write. It's the fast feedback. You like it. It's quite easy. And then if you're lucky, you have an integration test, some sort of an integration test, but it's a pre-Docker era, not sure you do. And then you have a lot less end-to-end test. This is the pyramid approach. So what happens when you actually use Docker, something really amazing happens. You can use a totally new approach, which I call the diamond approach. So the diamond approach, and this is the approach we use in logs.io, is quite simple. In unit test, we use only to test pure logic. I mean classes that don't require an external dependencies, something like an algorithm, some sort of transformers, adapters, pure logic. So we don't have a lot of those. Next, we have a component test. And this is the start of the heavyweight. We have component testing, as I said before. It's a unit test. It's like a unit test, but with the real dependencies, again, using Docker and Testcontainers. And now the heavy lifting. Most of our tests we do using integration tests. So the unit of work is a microservice. And then we can also, and then we have less, but again, a lot of end-to-end. So end-to-end, as I described before, you set up the flow of the test that you need. And then you test it like a black box from the entire flow of the system. And the reason, of course, is of course why we do it. And the first, I think, is confidence. So why confidence? When you look at it, when I looked at it, and when I approached logs.io, we saw that when you think about it, the old way of writing, the old way of getting confidence looks too cumbersome and it's too pricey. I mean, you have to, a lot of times you write your code and you throw it over the wall to a QA. It's not you, the actual developer who writes the test. So the old way, it gives you confidence, but it's very pricey. It's very high in price. And the new way, it gives you the same confidence you have, but with a lot faster feedback cycle. And the next thing, which is an answer to your questions, is an approach. So we value team autonomy. which means that we want, the same as some big companies like Spotify and other companies, are composing a team that is called a self-contained. So a developer is essentially, in this new continuous delivery approach, is responsible from end to end. So he designed the microservice, he writes the test, he deploys it using self-service tools, and he actually monitors it in production using many other techniques, right? Logging and metrics and alerts. So for him, using this approach means you don't really need a QA team. You don't need the handover, which costs time. Sometimes you don't really trust that it's written as you. So this gives you the ability, if you want, of course, it's something that you need to want, to be an autonomous team. And the third thing is about pragmatism, right? So you don't really have the time to write, of course, all the tests. Well, the magic button that we talked about before is instantaneous, right? You press it and everything is tested for every possible angle. But again, we don't have this magic button, and you don't have really the time to write everything. And I think this approach, essentially, when you think about it, it gives you a lot, of course, of developer velocity, because when you write a new code or when you change code, a lot of time it happens that you wanna reduce your technical debt. So you wanna change something, and I guess everybody witnessed that you change really something small, and then like 50 test breaks. And this is like the good sign, the good part. The other part is that the test doesn't break in compilation, but you run it and like 25 test fails. Like, oh no, you don't really want to, you get despaired and frustrated, and you decide to avoid this refactoring, but it's a good refactoring, but you decide to avoid it. What happens? You accumulate a large technical debt. And when I saw this approach, and that I've experienced it over the last 2 years in Logs.io, I think this is the lowest technical debt we do have, but it's like the lowest I saw. And I think one of the things that led to it is the focus of the diamond approach. When you focus on writing integration tests, what happens when you write integration tests that you need to focus a microservice, you can essentially troll around and refactor your code completely. Then you change everything that you can think about, and when essentially you test it from the public API perspective. You test what the microservice needs to do. And this enable, like for me, when I approach and refactor the log receiver like from scratch, and I just use the test. It gave me a lot of confidence to know as a new person, I refactor everything and just press play. And the developer velocity it gave me, I didn't need to go and fix so many unit tests and the business logic that you talked about, then you need to test. And again, it's an approach, and for me, I think it's really, and for us as a company, it really helped and gave us a high developer velocity. And one last thing that we'll wrap up is, of course, the trade-off. I mean, what is the trade-off? And the trade-off, of course, is time, right? Because the time, every approach you choose, you gain something and you pay to get it, right? You lose something. And what you pay here, that when it takes time to run the test, they don't run in milliseconds, they run in seconds, sometimes tens of seconds. You encountered problems that when you see like the test suite can take an hour and a half in the entire test suite. It's a lot of time. So one way of for us to work around it is break it to multiple Jenkins slave and run a group of tests in parallel. So this brings it down to 20 minutes. And that's about it. Thank you.